So of course you can also combine these techniques that we learned before to only, for example, do this stuff selectively, for example, based on a group. So I could also say that if I want to do, for example, a group over here, and then let's say I want to group by bounding regions, put it in here, and then I could say that I only want to transfer to stuff that's inside this group. So this needs to be primitive group, I think, group 1, destination group 1. Now you can see it only happens within this group. So you can see how we can already start using these couple of techniques that we learned up until now to start doing pretty cool stuff. Right, so you can see how powerful working with attributes is. So let's do some more with attributes. Let's start doing some other cool stuff. So let's put down a scatter. So that's a node that's frequently used inside of Houdini. So let's append it to our grid. And if we highlight, we see we get a whole bunch of points. We get 1,000 points, actually. So we can control how many points we want here. And of course, we can use all of these techniques that we learned before to maybe randomize whatever we're doing. So let's say we could put this z-scale here and then put it to set value and then set our density attribute to be z-scale, for example. And then it would like scatter more where the attribute is higher. So let's not do that for now, but just to prove the point that you can use these custom attributes almost everywhere to sort of like drive your effects. But let's just scatter regularly. So we have all these points here. All right, so now maybe what we want to do, maybe we want to copy some stuff to these points. All right, so let's type copy to points. You can see copy to points here. So put it down. So the first input will be the geometry that we want to copy, and the second input will be the points. So let's just first connect points to there, and maybe let's do not too many points yet. Now, maybe let's add a sphere. Let's put that over here. You can see right now, so our points will be copied to this point. So our sphere will be copied to these points. You can see we can increase and decrease the amount. And this, so the copy to points also can use certain attributes to sort of to change, for example, the scale of these copies. So let's make another attribute randomize. Let's put this to, let's type p scale and let's put it to 1. So you can already see something happen. So p scale is recognized by the copy to points. And what p scale basically will mean, so p scale stands for particle scale, and that will just be the size of the copies. So if something is 1, it will just be the exact size that of the object that it's here. If it's 0, it will be super small, and if it's like bigger than 1, then it will just increase the size of our sphere. So we can do similarly to what we, for example, did before. Is let's remove this thing, for example. Let's do an attribute transfer like we had before. Attribute transfer. So we already have this sphere over there. So let's say, let's plug in our z-scale into our attribute transfer. And let's do an attribute create on our points. Let's call this p scale. So right now everything is, well, disappeared because it's so small that we can't see anything. And of course, this is just going to transfer z-scale. It's going to be primitive. So it's not, nothing is going to happen in this case. But in Houdini, we also have the ability to sort of to rename or promote attributes. So let's first promote our attribute. Okay, but let's first rename it maybe. So if we type attribute rename, and let's put it over here. So we can see we get a renamer thing. So if you like middle mouse on this, we see we have a primitive attribute called zscale, but we don't want to be zscale. We want it to be called pscale. So attribute rename primitive from to. Okay, so it's called zscale. We want it to be called pscale. All right, so now it's called pscale, not zscale anymore. Tscale, pscale. Of course, we could have also just created an attribute here, but this is just to show you that we can sort of just manipulate and rename stuff on the go as we want, as we are going along. Of course, nothing is still happening because this needs to be a point. It needs to be a point attribute. So let's type attribute promote. So promote will promote it from a primitive to a point, for example, or from a point to a primitive, or primitive to detail, like whatever class it is, and put it into another class. So let's go into our spreadsheet. So you can see, because this sphere is just one point, because it's so it is. You can see right now it is a pscale on the primitives. And if we go to our attribute promote and then put it to from primitive to point, and then on the thing here, let's put to pscale. You can see it disappears here, and it moved it to this thing here. So of course, right now this promotion method doesn't really matter. But let's say you're gonna go from points to primitives. Then, like, let's say this is 4 points, but it's one primitive. So the promotion method will like take the average or the maximum or whatever. So, but we'll get more into that later when we're gonna use this more often. But for now, just remember that you can just move stuff around, so you could move it from primitive to points or whatever. So now we moved it and we made it into a pscale attribute. All right, so now if we go to copy to points, you can see everything is big again, and that's because our so it is already transferring it, but let's now specifically say we only want to do pscale. So let's transfer pscale, put it in there. Let's turn off primitives, and the size here is just quite big, so let's make it smaller and let's increase the blend width. And I'm a little bit annoyed by the ramping that I did, so maybe open animation editor, just select these keyframes, and over here on the top we can like say how they should like behave. So let's make it make them just be linear. So now you can see that our copies are being driven by the pscale attribute. So if we just play through this, you can see we are using this attribute on the sphere here, and we are transferring it to our points, and then we are copying an object to it. And this doesn't have to be a sphere. I could make this a pig. Put it in here, put the pig on there, and then you can see it's copying pigs. You can see, maybe already depending on your system, you can sort of see that this is starting to become a little bit slow. So just I'm going to talk a little bit more about that later, but for now, if we go to our copy to points, you can turn on pack an instance. If we do that, it's already a lot faster. Okay, so what did pack an instance do? Well, if we turn it off again, you can see if we press S on the keyboard and then maybe go to point selection, we can see we can select the individual points on our pigs. So that's because this is just copying the pig and making it a completely new object. So completely new points. And if we go to our geometry spreadsheet, so we have a whole bunch of points now. We have almost 700,000 points. But you might say that we don't really need individual like elements right now of this pig, because it's just it could also just reference the pig in here, right? That's what pack an instance does. So pack an instance. So if we now middle mouse, you can see we only have 240 points, which is how many points we have in here. And what it just now does, it references back the pig over here. So it will just take this geometry and reference it and put it onto the points. So in general, if you're dealing with a lot of points, you kind of always want to you always want to instance. Of course, right now you cannot really individually edit any of these pigs. But well, of course, I mean you can if you want. So, but like right now, if I want to select stuff, screwing up my camera. So if I want to select stuff, I mean I can. It will just be selected as being points. So if I turn off my points here, turn on my points, and I can say that I just want to select a couple of pigs here, delete, and then can put delete non-selected. So now we only have these points. And now what I could say is that I want to unpack these pigs. And now we can see if we put unpack, they are no longer instances. And now I can manipulate these pigs. So I could do a beautiful transformation with a little bit of a soft radius. And I could say that, so I blasted them away. Then I could say that I also want to have the inverted one. Then I could say I want to merge those together. Template, and now you can see that. So I still have the ability to sort of do this thing, because now I selectively just unpacked these couple of pigs and then doing this manipulation. So I'm going to delete this again, but just keep in mind that is basically what packing is. And if you're dealing with a lot of geo, and if you're copying a lot of geo, you kind of want to you want to use packed. That's also, I don't know if any of you ever used Cinema 4D, but MoGraph, for example, didn't use packed up until like one version ago. I don't know when I think they introduced instances in R20, if I'm correct. But before that, that's why MoGraph was so slow, because it wasn't using any instancing. I mean, right now they are, but generally, if you're using with a lot of copies, always use packed, and then unpack whenever you need it to. So whenever something is packed, it's being treated as a point. So keep that in mind. So everything that's packed is going to be treated as a point instead of a separate geometry. And that also makes it super powerful, because then you can also do other stuff with it. But the copy to points also knows can deal with more types of attributes. So what I could also, for example, do is if I put down an attribute randomize here, I could now also if I type scale, you can see something already changes. So where p scale is sort of a uniform scale and will like uniformly transform the copies, scale will do it like based on the individual axis. So let's say I only want to randomize maybe the y scale. So let's put the minimum value to 1 to 1, and then we have the max value here, and then maybe we want to increase let's do it like this. So now you can see we are randomizing the y scale. So the whole thing with the p scale still works, but now the y scale will be randomized. That's cool, right? So there's more stuff that the copy to points recognizes. So for example, there's also, if we put another attribute randomize, if we put, for example, n, the normal, so normal copies will orient into the normal direction. So if I turn on normal visualization, you see right now I get stuff pointing in like I get random normals. So if I go into my geometry spreadsheet, you can see I have normals. So if you don't know what normals are, let me just make a regular geometry. And if I put down a facet, so by default, every object has, so you can see these normals are now green. So those are vertex normals, and it has intrinsic vertex normals. So by default, it just has vertex normals by itself. But if we want to do like geometry, like position manipulation, then it need to be point normals. So you could say if I put down a facet, then I can turn on post compute normals. You can see now I get blue normals. And you can see what a normal basically is just the direction that each point is facing. So it just flows sort of along the surface. As you can see, it just points outward from every point. Anyway, so you can use these points to sort of orient your copies. Let's say if I were to copy something to this pig, let's say I make a box and let's say I make a box that is too high. Let's do it like this. Let's put it to 0.2, 0.2. Right, so let's say I have this box and I copy it to the pig. That's beautiful. You can see these copies will point towards the normal direction. But that also means that I can randomize my normal direction. So if I do that, I kind of want to put it so by default it will just do it basically like this uniformly. I can also put it to inside sphere. So then it will basically go in every single direction. So now I get normals that are randomly oriented. Let's put these randomly oriented, like just 360 degrees. And now my copies will be just grow in random directions. You can see right now they're sort of, I guess like spikes or something. And of course, this is all still very much procedural. So we can take this scatter, we can make it less copies, we can make it more copies. It's instanced, so it's like it doesn't matter. Like even if we have a lot, I mean it'll be a little bit slower, but you can see it's not that bad. So right now we have like just over 22,000 copies. You can still, it's still quite fast. You can see how that is like quite cool to be able to use like attributes to manipulate your geometry. And again, like this is the main thing about Houdini, is just making attributes and just using them to drive your stuff. And again, these like a lot of attributes will be familiar, like will be recognized by stuff in Houdini itself, like CD or N or P scale or scale. So those are attributes that are known to Houdini nodes by default a lot of times, but they can be like you can name attributes anything you want. You can have custom attributes to sort of hold data to use it in another spot later on. So I know that might sound a little bit confusing, but we will start using that more and more and more the further we dive into this course. As long as you understand right now is that how these things are being scaled and what we are doing here. So we're just making an attribute, transferring it to our points, and then the copy to points will sort of manipulate the copies based on that attribute that is put on there.